안녕하세요. 저는 서울대 법학전문대학원에서 조교수로 재직 중인 박상철입니다. 웨비나에 참석해 주셔 대단히 감사드립니다. 오늘은 서울 AI policy 컨퍼런스의 2020년 시리즈 AI와 시장, 투명성, 공정, 혁신의 네 번째 세션입니다. 구글의 글로벌 신기술 공공정책 전략 부문을 이끄시는 Charina Chou 박사님께서 인공지능 거버넌스에 대한 구글의 시각을 주제로 발표를 하시겠습니다. 연사께서는 스탠포드에서 화학을 전공하시고 UC 버클리에서 나노기술로 박사 학위를 받으셨으며 전미과학재단과 재료연구학회에서 수상하시는 등 탁월한 학문적 성취를 이루신 후 오바마 정부 때 과학기술정책 분야 백악관 펠로우로 봉직하시다가 구글에 조인하셨습니다. 이러한 탁월한 경력과 더불어 구글에서 축적하신 다양하고 글로벌한 경험을 통해 멋진 강연을 해 주실 것으로 기대됩니다. Q&A는 채팅창에 궁금증을 영문으로 올리시면 제가 발표가 끝난 후 취합하여 여쭤보겠습니다. 줌에서 한글 자막을 보실 수 있으며 자막 설정을 통해 크기 조절이 가능합니다. 이와 더불어 동시 통역을 유튜브 채널에서 제공하고 있사오니 채팅창에서 안내해드린 링크를 참조하여 주시기 바랍니다. Good evening, Charina. I just introduced you and your fascinating career to the audience. I know it's dinner time in the West Coast, so we really appreciate you joining us all the more. You'll have 40 minutes for your speech, and a short Q&A session will follow. So I'll diligently collect questions from the audience while you are talking. Thank you so much, Charina. The floor is now yours.
Thank you, Sangchul. 안녕하세요. Hello, everyone. It's great to be with you. I think if we can start the slides as well, I'm really glad to be here to share a bit with you on Google perspectives on AI governance. So why are we all here talking about AI? Next slide, please. I think everybody recognizes that AI really is powerful. It can help address challenges around the world. Shown here on the slide are just a few of the many, many snapshots that we've heard around the world of people using AI to address important challenges, both local and global. So why is AI important to Google? Well, most importantly, AI enables Google to deliver on our mission. So I've shown a snapshot of the search bar here, the Google search bar. Many of you may know that the Google mission is to organize the world's information and to make it universally accessible and useful. Now, when Google was first started more than 20 years ago, search was very different. When somebody would search for something, let's say Korea or the United States, the results would be 10 blue links, and it was largely links to text on websites, and people would search fairly simple questions. Today, that's completely changed, right? People are no longer just searching in English. They're searching in hundreds of languages. People are no longer just searching simple phrases like Korea or the United States or coffee shop. They're searching much harder queries like coffee shop near me with more than 4 stars and a wonderful ambiance. The content on the web is also much more complicated today. It's no longer just text. There is a lot of video and audio and images and all sorts of content. I mean, it's no longer possible to just answer everything kind of in a pre-programmed, hard-coded way. We actually have to be moving to more techniques like machine learning to learn and adapt and actually continue to serve our users. So this is just a search example, but you can imagine many more even at Google around spam detection and maps and directions and estimated time of arrival, things like translation. There's a lot of reasons why we are placing so much importance on AI at the company. Beyond just Google, though, we're recognizing that a lot of the tools that we have been developing are useful in many other sectors. AI can help, for example, in health. This is an area of a lot of opportunity. So I've shown here on the slide a tissue stain from a cancer patient. And if you look at the stain, I think these are very common for doctors to take a slide of patient samples and actually to take a look and say, all right, What does the disease look like in this patient? Now, if you all take a minute to just look at this slide, and if I asked you, does this patient have cancer or not? I think it would be very difficult for most people on the call to be able to say yes or no. And actually, beyond that, here's where I see the cancerous cells. A lot of pathologists actually need many, many years of training to be able to see things like that. But with the help of machine learning, training models on many examples, you can actually come up with a model now that could identify for you not just whether or not this patient has cancerous cells, but even where they are. The cancer metastases here on this slide are shown in red. So we see many opportunities and many great ways for the tools that we're developing inside the company and for the tools that many others are developing in the world to be used for wonderful applications like health. However, and as with many technologies, the use of AI raises new questions and risks. So I've shown here on the slide a photo of lips. Now, 2 years ago, we were approached by a hospital in the UK. And this hospital said, we have a large number of patients in our hospital that have a condition called aphonia. Aphonia is a condition where patients are able to speak and think and act clearly with full capacity, but the one thing they are not able to do is actually vocalize the words that they are saying. So when they're speaking, they're thinking, and all of these words are being said, but no sound actually comes out. And it's very difficult for them to be able to communicate directly with family and friends. So this hospital in the UK approached us and said, Google, we've recognized that you're doing a lot of work in neural networks with new machine learning models, and we wonder if you can help us. We have a large number of patients with this condition, aphonia, and we think maybe you would be able to develop a neural net model that could help these patients communicate with their families by enabling them to read lips. Now, here's a question for everybody on this call. If you continue to just go back, please. Here's a question for everybody on this call. Would you develop a model like this? So the benefits are obvious, right? Who wouldn't want to help people communicate better with their loved ones, with their families and friends? It's a wonderful application. That being said, a lip reading model raises new questions and risks. Who would have access to that lip reading model? Would you publish that model? Would it be open sourced? What if somebody with malicious intent had access to that lip reading model? What about governments? Could people use it to spy? What are the privacy implications? Is it going to work well for all different kinds of people? What are the possibilities of both good and bad that this kind of model should be used for? And then should we develop something like this at Google? So this was a real question that we faced. And this is just one of many, many examples, these types of questions where we saw enormous potential opportunity, but also questions. And as we started to assess more and more of these cases, it became very clear that as a company, we needed to develop our own framework for assessing these new opportunities and risks. So in 2018, we released a set of Google AI principles for responsible development. You can see here on the left, I have noted 7 things that we outlined in our principles that AI should do or be. Number 1, AI should be socially beneficial. That's the entire reason for us pursuing AI in the first place. All of the wonderful things that we talked about on the earlier slides, there's so much opportunity here. We absolutely should pursue AI for all of these socially beneficial reasons. That being said, we also identified that AI should avoid creating or reinforcing unfair bias. AI should be built and tested for safety. AI should be accountable to people. AI should incorporate privacy design principles. It should uphold high standards of scientific excellence. And then number 7, AI should be made available for uses that accord with these principles. Now, this last one that's noted, number 7, really gets at the point that we recognized we were developing a lot of really cool techniques and technologies inside of the company, And we also recognize that Google only works on a fraction of the world's problems, right? There's really important problems that we're working on, but there's so many more problems outside in the world that many others are working on. And we wanted to make sure that any AI that we developed should be made available to others for all of the problems that they cared about, for uses, again, that accord with the principles that we've laid out. In addition to the 7 things that we identified that AI should do or be, we also identified 4 red lines for ourselves as a company, applications that we as Google will not pursue. So number 1, we will not pursue AI applications that are likely to cause overall harm. Number 2, whose principal purpose is to direct injury. Number 3, applications with surveillance violating internationally accepted norms. And number 4, whose purpose contravenes international law and human rights. So these were principles that we set out, both 7 things AI should do or be, and 4 red lines, applications we will not pursue, to really guide the development of AI at the company. We said this is a framework for us such that every time we have these cases, like lip reading, like many of the other cases that are coming to us, we actually have the same framework that we can use to assess each time. Next slide, please. So how do we actually implement this? Well, first of all, technical practices are part of the solution. So you can see here, I've noted data, models, and testing. These are 3 areas where we can actually develop some technical tools to solve some of the hard questions and new risks and new open challenges that we're facing. I'll share just a few examples to make this concrete. Next slide, please. So first, one example is this idea of nutrition labels for data sets and models. This is something that we are developing at the company. The idea here is shown, for example, on the left. If I was going to eat a bag of pretzels, so let's say a snack, I might see the pretzels, but I actually don't know what went into those pretzels. I want to have an idea of what went inside so I understand what I'm consuming, what I'm eating. So you can see here, of course, many different snacks and foods now have nutrition labels on them. So instead of just eating the pretzels and thinking, hey, like I think this will be a great snack, I actually can understand what is inside there. I can understand the total fat, the cholesterol, the sodium, the carbohydrates, so that I can make more informed choices when I'm at the supermarket of what types of snacks I want to consume. We took this idea and applied it to data sets and models. So right now, a lot of machine learning models are trained on data, for example, but it's not always clear where all of the data comes from or what is composed inside of that data set. One thing that we've started to do is develop what we call data cards and model cards, essentially nutrition labels for data sets and models, so that whoever is using them to build an AI system can actually understand what's inside. So I've shown an example here from a data set that we have called Open Images Extended. It's a full data set of many different kinds of images from around the world. And instead of just publishing the data set, making it open and having anybody use it for whatever applications, we've outlined key items about the data set so whoever is consuming the data set can make more informed choices about whether or not it will make sense to use it for the application that they care about. So you can see some examples here. We can identify, not just what is in this data set, it's open images, but what kind of intended use cases are here. It's intended for objects, plants, animals. It's intended for these types of use cases, and maybe people can make more informed choices. Another example of a technical solution is actually crowdsourcing more diverse and representative data. So shown here is an example from an app that we have called Crowdsource. One of the things that we noticed was a lot of the data that we and others were learning from with respect to machine learning models was actually heavily weighted towards data coming from the West, from the US, from Europe. And actually, if you looked at things like search for wedding or bride, you would see a white dress in a lot of the results. And that may be true here in the US, but that's not necessarily true in other countries around the world. For example, in India or other countries where there may be more traditional, different dresses than just a white dress for a wedding. So one of the things that we've identified and that we're continuing to work on is this idea of actually crowdsourcing more diverse and representative data so that when we train models, they can actually be trained on data that's representative of not just one or a few populations, but populations around the world. You can see here a few categories like mountains, waterfalls, lakes. We know that mountains actually look different in different parts of the world. So how can we make sure that we're collecting and sharing more representative data sets? Now, I outlined on the slide about technical constraints and solutions, data, models, and testing. We know that as much as we try to make data as perfect as it can be, right? As much as we try to outline labels for the data sets, as much as we try to gather representative data sets, no data set in the world will ever be perfect. That's illustrated here, something that we actually had in our Google Translate product. So when we would translate from Turkish to English, Turkish is a language where there is no gender differentiation in pronoun. Whenever somebody would enter "O bir doktor," in English, it would always come up as "he is a doctor." O could mean actually he or she. It could be referring to a man or a woman. But in fact, because of the huge bias in data towards many more examples of male doctors, we would always see a result, he is a doctor, because the machine learning model was learning on data that saw very many male doctors. Now, one of the things that we did was to say, all right, we know that in all of the data in the world, all of it, there are biases in the data. There actually are existing biases just in the world. So what can we do to actually build fairness constraints into the model itself? What we did was actually to build constraints such that now in Google Translate, if you type in "O bir doktor," for example, in Turkish, you will actually see two results in English. You will see "she is a doctor" and "he is a doctor," with an opportunity to learn more. And then whoever is using this tool can actually select which makes the most sense for them. There's also an opportunity beyond just data and beyond just models to test what a model has learned. So we get this question a lot. For example, let's say that we have an image of a zebra and a machine learning model, computer vision, that identifies and said, all right, this is a zebra here. I see a zebra. Now that's correct, but we get a lot of questions as to how do you know that that's a zebra? How can I trust that this is a zebra, right? Let's say that it was incorrectly labeled. Let's say that it had said giraffe or elephant. Now that would have been a mistake and maybe a funny one at times, but you can imagine cases where this would be much more serious. Imagine this is not an image of a zebra, but in fact an image of a cancer patient or an image of a stoplight in front of a car. Well, you actually would really want to be able to understand how good the model is, why it's making the decision that it did, why a certain recommendation is there. Sometimes people will refer to this as algorithmic transparency. I want to understand not just the end result, but how the model came to that result. So one example that's been developed by my colleague Bin Kim and team is this idea of testing concept activation vectors. So to understand what the model is seeing, why it labeled something as zebra, Bean and her team have developed a tool which we call TCAV to actually look at what might be leading the model to come up with the answer zebra. So let's take the example of stripes. Well, taking a partial derivative of zebra-ness relative to stripes, we can get a sense of how important stripes are to the model deciding that this is a zebra. You could do the same thing. It doesn't just have to be the concept of stripes. It could be the concept of spottiness or polka dots or black or white or grass. You can test all sorts of concepts and try to get a sense of how important they are to the final answer that the model sees. In this case, the stripes concept came up with a score of 0.9, the max here for this derivative being 1. And you could conclude that actually stripes was very important to the zebra class of finally making this decision for the image. And you can imagine applying this to many other cases, and that's something that we're continuing to work on. So these are just a few examples of the many that we are working on in terms of technical solutions, technical tools. If you're interested, I recommend that you can go to the Google AI website. On the top, you'll see a tab called Responsibilities. We actually have something that we've called our responsible practices, general recommended practices for AI. Now you'll note that we call them recommended practices and not best practices because we think actually the field is still in a new stage. Nobody knows at this time exactly what's best, but we do know what are more recommended, and we continue to update this website every quarter, updating it with the things that we're learning as well as the things that we're seeing from others, so that we as an industry and as a field can all help each other to get better in responsible technical implementation of AI. The website includes technical tools for general practices as well as fairness, interpretability, privacy, and security. Now, in addition to technical tools, operational processes are also important, right? It's not enough just to have wonderful data sets or models. You also have to have the right processes in place. This is something that became very clear to us as we started to implement the AI principles at Google. We identified 4 key components in our process at the company. The first is really culture. This idea of training, this idea of hearing from others. You know, it's wonderful to have a set of AI principles, but how do you actually implement that? Well, you need each person at the company to actually have that embedded in themselves for them to be aware and empowered and informed to be able to act as they are implementing AI themselves. So something that we developed was a number of training series, a number of speaker series, both internally and externally, so people inside the company could hear from others. There are more than 100,000 employees at Google, and it was very important that this not just be a decree kind of outlining here's what we aspire to, but in fact something that every single person at the company could internalize and know how to think about and how to act. A second part of the operational processes were really the technical tools, some of which I talked about earlier: data, models, testing, publications. How do we make sure these tools are not just developed, but actually have the processes such that they are shared, they're easily accessible, they're easy to understand and easy to operate? And this is something that we've been working very hard on. We also recognize the importance of review processes. Now, I mentioned, for example, the lip reading case that we had. And since we launched the AI principles in 2018, we've actually reviewed hundreds of such cases. One thing that we really wanted to do was not just review each of these on a case-by-case basis, and now we have the principles and we have a framework to assess them. That's all wonderful. But what are we doing to actually learn? Something that we do for each of the cases is actually document carefully, going through each of the principles. We outline 7 things that AI should do or be, 4 red lines that we will not cross. For each case, how can we assess each of them in a systematic way with respect to our principles and document the final decision that was made? This is important for us in many ways. First, to really understand and be thorough and think through the decisions that we're making. 2, to actually have something documented so we can go back to it in 3 months, in 6 months, in a year, and say, all right, knowing what we did now, let's look back at the case that we developed. Was that the correct decision? Was there something we should have done differently? What new information do we have now so that we can iterate and update and improve on the decision making that we have? A third reason that these case studies are important is they set up a pattern of sorts such that each new time we don't have to come back to the drawing board and recreate our decisions from scratch, but we can actually look at previous cases similar to case law and actually have a sense of what we're doing, what's worked well, and what new improvements we can make so we can be making the very best decisions. As part of these review processes, we've also been developing many frameworks. The principles are wonderful, but what do they mean specifically for individual cases and types of technologies like facial recognition, like synthetic media and generative models? There's a lot of questions like that, and we've been developing frameworks to really be able to assess more specific cases in a consistent way. And then finally, this idea of escalation is important. We actually have a process at the company where anybody, any one of the 100,000 plus employees can actually flag a case for review. So a lot of people, again, with culture, internalizing what's available, technical tools, being able to use that and implement and make good product decisions. But in cases where they're tough, where they're not sure exactly what to do, where they've maybe discussed with their team and there's a lot of issues at stake, we have an escalation path. So any Google employee can actually use that. And we can actually go through a series of different review bodies, bringing in different experts to come to a final decision. Next slide, please. Finally, the last piece of this operational process is really this idea of community exchange. So it's wonderful for Google to be doing a lot of these things. And as I mentioned, there's a lot that we can be learning even within our own company. That being said, we absolutely need to be in exchange with the larger community, the external world, right? There's certain ways that Google is looking at some of these problems, but we know we're just one of many voices in this space, and there's so much that we can learn from the external world. So we participate in things like this through conferences, through consultations, where we may have a sticky question and we actually work with different groups from government and civil society and academia and others to actually get a wide variety of perspectives and try to come to a better conclusion. Reports as well. I mentioned that we've documented a lot of these case studies. One of the things that we've been doing is each year since we launched the AI principles, actually putting together a report of some of the things that we've learned, some of the cases and the decisions that we've made, and sharing those externally. You can find them on our Google AI website so that we can share what we've learned, and we can also gather feedback and hear from others on any improvements or suggestions or ideas that they have. Next slide, please. So technical tools are important. Processes are important inside of the company. Public policy has an important role to play as well. I think many of you in the audience are having a very important role here, right? I'm going to share some ideas that we have and would really welcome other ideas that you all have and have been working on. So next slide, please. One idea is in this category of smart investments, thinking about governance, right? Open data sets. We've talked a bit earlier today about the importance of data, how important data is to actually training models, to enabling learning and better predictions. Well, governments actually have huge troves of data. In fact, some of the largest data sets worldwide. What can governments be doing to actually open up those data sets? At Google, we've got dozens, I believe more than 70 data sets that we've posted from the data that we're learning from and training from. We have those on our Google AI website. The same thing for governments. We've seen lots of governments start to open and unlock data sets because there's enormous value there. I will point out it's not enough just to open up the data sets. It's very important to note that what's being done to make sure these data sets are machine readable and also clean. There's a lot of data out there. A lot of it is messy and dirty. And in fact, if we're learning from faulty data, that could actually lead to more faulty machine learning systems. So open data sets, what can governments and policy do to actually open up more data and to make that accessible and useful and productive for society? Next slide, please. I talked about this idea of data cards and model cards and things that we're doing at Google, continuing work there. These are smart investments that governments can also make, right? For the data sets that they own, for the data sets that they collaborate on, what can governments and policymakers do to actually make those data and model more transparent? What can they do to actually help users understand what's inside of them? So can governments do more on data cards and model cards? Next slide, please. Another idea for smart investments is very important. It's this idea of training and education. Now, I'll pause here to note that, in fact, we've been doing a lot of training and education inside Google ourselves. 5 years ago, when I joined the company, actually fewer than 5 or 10% of our engineers had machine learning training. That's completely different today. Now machine learning is used in every single product across Google. There was a lot that we had to do for training for the new role that machine learning would play and the new kind of skills that were needed for the jobs as we saw products moving into the future. I think it's the same thing. Governments have an enormous role to play in training and education. They have a lot of information on what kinds of jobs may be important, what kinds of jobs may need which skills. And so governments can actually really invest in and support this idea of new training and education. Next slide, please. Finally, this idea of AI for public services. So we've seen a little bit of this already in other, in various governments, both state, local, and country around the world. What can governments be doing to actually use AI, not just support AI, not just invest in AI research, not just partner with universities or companies, but actually what can governments do to use AI themselves for public services? There's really an opportunity there for governments to set an example of responsible and beneficial use of AI to serve the people. A next area, or a kind of a bucket that we identified, was this opportunity of areas for clarification. So explainability standards. We talked a bit about algorithmic explainability. Why did the model label this as a zebra? You can imagine, for example, in a health case, that explainability standards are very important. People want to be able to understand, why did a model say this patient has cancer? That's a very important thing to understand. However, it's not always clear what exactly the level of explainability is that will be important and useful, right? Sometimes we hear, well, for full transparency, it would be best to just release the source code. If you release the source code, of course, that's not always the most useful. It's not really even necessarily apparent to many developers. What does that source code do? Why is that important? And how does that actually enable the model to come to a certain answer? But explainability is important. So can governments, can policymakers help to identify what these standards are? If machine learning models are being used in a health system, in a doctor's office, what kind of explainability, what kind of levels of explanation are important for the doctor? What kind of levels of explanation are important for the patient? What about the technician? What about the patient's family? What about the insurers? There's all different levels, and it's very important for this to be a larger discussion and for governments to weigh in, right? I think Google, for example, sees huge opportunities in the health space, but we would not be the experts of exactly what level of explanation is essential or needed or helpful for all of these different parties. So governments have a big role to play here. Next slide, please. Other areas of clarification include, for example, human-AI collaboration. We hear this a lot. Humans in the loop, human-AI collaboration. But where is human collaboration important, right? You think about a calculator. Well, we don't need a human to be in the loop for that calculation. You can tell the calculator 4 + 3 = 7 and get that answer, and that's great and efficient, and people can move on. But what are places where humans should be in the loop, either because it is a really important decision where human needs to be part of it, or because it is a dignity question where, you know, humans and the nature of the situation really should be part of the conversation. This would be a wonderful place for policymakers, governments to really provide guidance and clarification. Open source and publishing. Again, I mentioned this idea of lip reading. Do we publish that model? You know, the more there are universal standards of what is okay to share and publish, and where you know, collaboration can be very useful, and what might be better to be kept more tightly controlled. These kind of areas of clarification are really big opportunities. Next slide, please. A final area where public policy can play a very important role is this idea of updates to rules. I have an icon here, which is a plant, because plants are growing. Technology also always evolving, always changing, and it's important for the rules, of course, to be flexible enough to adapt to that. So as it comes to AI, a few ideas that we have here. First of all, it seems very important for any rules to be sector specific. So if you think about it, AI is essentially at its core just math, right? And you wouldn't regulate math the same as we don't regulate chemistry, but we do regulate applications of chemistry in specific situations. The same thing, if AI is used in a healthcare space or in the transportation space or in the law, what are these sector-specific laws that can govern and actually help to make sure the technology is used in the most beneficial way? Existing gaps. I think right now there actually are a lot of laws out there that are technology agnostic. So it doesn't matter actually what kind of technology is being used, whether that is AI, machine learning, your standard linear regression models, or any other kind of models. And so there actually are a lot of laws that already cover kind of some of the new applications of AI. But I think it's very important for people in the public policy space to really take a careful look at various laws and see, all right, out of what already exists, what, if any, existing gaps are there, and how can we start to address those? Next slide, please. A final idea that I'll mention in this area is really this idea of revisions to reap AI benefit. There's so many benefits that can come from AI. So how are the laws built so they are flexible enough to gather them? As one example, right, we're seeing a lot of opportunity in the health space, as I mentioned. For example, learning from medical records. If you could actually learn from many people's medical records in a privacy-preserving way, you could actually maybe come up with better insights that could serve everybody, could help people and healthcare systems all around the world. But the laws are not currently in place to be able to do that. So what revisions are needed to reap AI benefit? Next slide, please. One point that I'd like to make is, as we know, all of these importance of responsible AI and all of the, technical processes and operational processes and actual kind of new public policy partnerships to actually put responsible AI into place, it's important to note that AI can also help humans to be more responsible. So this here is an image of a collaboration that we did with the Gina Davis Institute. And Gina Davis had this idea in Hollywood that there was actually systemic bias against women. And Gina Davis and her team said, we think looking at movies that, in fact, men are more frequently featured than women. Men have more screen time, they have more speaking time than women, but we don't have a way to actually quantify that, to actually get the numbers around that. So they came to Google and said, can we partner with you on a project to actually use computer vision models to look through millions of hours of movie footage, right? This is something that no human could ever do. Nobody could ever sit in a room and actually watch millions of hours of movies and put boxes around men on screen versus women on screen and actually also quantify, how long were they on screen, how long did they have speaking time. But this is something that a computer vision model could do. And so one of the things that we found in this partnership was actually, in fact, men do have more screen and speaking time than women. About 70% of the time is men. And furthermore, we actually identified that movies that had females in 50% or more of the screen and speaking time actually did better at the box office. This is a result that you would never be able to get from manual kind of human just searching through all of the footage. And so this is something that Gina and her team have been able to take to Hollywood producers and companies and actually identify the need for more opportunities for women to be in screen and speaking time roles, featuring them in the movies. Last slide, please. So I'm going to leave with this idea and this slide and this picture of what's next from Google AI. And again, happy to go into any of this in more detail in the Q&A. What do we see coming next? Well, we see cutting-edge research. There's a lot of work going on in basic research in AI, large models, generative models, small data, unsupervised reinforcement learning, quantum computing, robotics. Enormous opportunities here to get even better models and predictions and opportunities. Second, applications. We're seeing applications in many different sectors, in business, in science, health, art, public services, and social good. These are a lot of things that we're working on in partnership with many different universities and nonprofits and other organizations around the world. And finally, this idea of human AI interaction. AI is wonderful, but it's really important. The whole reason to do it, again, is for societal benefit, for human benefit. Humans have to be able to use it. So what are the interfaces that we're developing? How do we make sure there's ease of use? How do we ensure wide participation, right? So it's not just usable by people who have a PhD in machine learning, but actually everybody can benefit from the advances in this technology and actually participate and be able to reap some of the massive opportunities. So I'll leave it there. I hope I've been able to really share just a picture of how we're thinking about AI at Google, and I'm happy to take any questions.
Thank you very much for the truly insightful speech. I'm so impressed, and I bet everybody here feels alike. Meanwhile, I collected several questions, but let me start with my own. My question is how Google has addressed the potential trade-off between ethical constraints and the performance of machine learning models. For example, there can be some voices requesting the suppression of important variables that are dispositive of future outcomes, but have some complicated social implications or sensitivity. Could you share some views or best practices that Google has implemented to deal with such tricky situations?
Definitely. It's a great question, and we've come across this many times. If I can, I might use the lip reading example that I brought up as one case study. So again, this was very tricky ethical considerations. There's could be enormous, wonderful performance of the model, for example, but we had questions as to whether or not we should even pursue something like this, and what kind of protections we might put in place. So the first thing that we think about is technical constraints. In the lip reading case, one thing that we did was, and, we had a lot of questions. We heard from human rights and other groups. If you develop a lip reading model, think about all the surveillance cameras that are outside, CCTV cameras and others. Could that lip reading model be used to just spy on people having regular conversations on the street? And so one thing that we did, which was very important, was to make technical constraints in the model. So it actually only performs well for somebody speaking directly into a camera at a 0-degree angle. It also requires a certain spatial and time resolution such that it's got great performance for these types of patients and actually very poor, terrible performance for anything in grainy videos or at an angle or posted from a camera high up. So that's, one thing that we look at is what are some technical solutions that we have. A second is this idea of really how do we learn from others and hear what the right standards should be, right? So you mentioned ethical considerations, performance. We know that there may be amazing performance for something, let's say in a health situation, but what happens if somebody really needs to understand? So in the lip reading case, let's say it's accurate 99% of the time, but what about that 1% of the time? If it's not correct, how do we think about it? How much explainability needs to be built into the model before we would even release something like that? And that's something where we gather a lot of external information. We work with various groups to identify what should those barriers be for quality and for kind of level of explainability in this case, and then identify what makes sense for a trade-off. And then finally, for us, it's been very important to document these decisions so that we can outline how we're making the decisions, and so people know, have some insight into the thought process, and can actually share feedback, and we can actually improve over time as needed.
Thank you so much for your answer. And I got the first question from the audience. This is very closely related to my first question, but from a slightly different angle. That's about engineer resistance. Sometimes developers don't feel comfortable talking about fairness and other related ethical concepts. They often care more about accuracy, performance, and speed. Fairness may have many metrics which are not always measurable or clear enough to developers. Do you face some types of resistance or tension in this respect? How do you reconcile?
Yeah, this is another really good question. It's something that we are very much focused on at the company. To use the example of fairness, there aren't necessarily very clear and well-defined metrics. So, for example, before any product launches at Google or any new feature, it has to go through, every single one goes through a review. And we've got a very clear security review, right? There are very clear security standards. Goes through privacy review. There's very clear privacy standards. But when it comes to fairness, it's not always obvious what's needed. And I think that's right. I wouldn't necessarily say there's resistance from developers, engineers, researchers inside of the company, but I would say there's a recognition that they may not be the experts in that area. So they may not know exactly what is required for fairness, right? If I've got an image search tool and it works wonderfully, how do I set the quality bar? How many different skin tones does it need to work on? How about different genders? What about different ages, different accessibility? What's correct? And we know actually no model is going to perform exactly the same on everybody in the world. That's just impossible. But what are those quality bars that are needed? So something that we've really been doing to address this has been to make sure we've got all sorts of different people at the table. So we have social scientists, philosophers, ethicists, legal specialists, all different types of voices and expertise to weigh in to identify not just for a specific situation, but what are the fairness metrics that we are trying to build towards. And when we have kind of more robust and more reusable frameworks, we can actually apply them in many cases, and then technical engineers can get more comfortable with identifying what they need to build for. But it's not a solved problem, and we're still working on that.
Thank you again. And the second question from the audience is about Google AI principles. We see a list of negative values that Google does not pursue, and see a term over harm and direct injury. Could you please make a clear distinction between the two terms?
Yes. So that is a great point, and it's something that we actually thought very carefully about that wording. So you'll notice if you look at the Google AI principles, in the 4 things that outline AI applications we will not pursue, 3 of them are very specific. That's numbers 2, 3, and 4. Number 1, as pointed out by the person who asked the question, is quite general, and we actually wanted to put it there in broad terms so that we could be flexible. I think we knew in 2018, even when we were writing these AI principles, we don't even know exactly the directions that the technology will take, right? We don't know all of the questions that we're going to face in the coming years or decades. And in fact, we wanted to set up a set of principles, an ethical charter that would be flexible enough to deal with various kinds of technologies and potential implications. So the idea of overall harm, that was something we put in, and that could actually be physical harm. It could be economic harm. Something we haven't talked about yet is this idea of, future of work, impact on jobs. That could very much be something here. It could be environmental harm. How do we think about the use of machine learning for, let's say, oil and gas companies? Or how do we think about even machine learning itself? It uses a lot of energy in the data centers. So what's our thinking about kind of the sustainability behind the models that we're developing? So we kept that quite loose intentionally. And as I mentioned, each case that comes for review is assessed in a very systematic way. And that question is addressed where we document all considerations and then update as needed.
Yeah, thank you. And the last question from the audience is about the abuse of Google's technology. I mean, Google has made publicly available many valuable toolboxes for fairness. And because the technologies are very scalable, they can be vulnerable to outsiders' abuse or attack. So in such case, how Google will deal with such a situation and coordinate with the government who might want to stop that technology?
And Sangchul, sorry, it broke up a little bit for me. Can you repeat the first part of the question?
Yeah. It's about the potential abuse of Google's technology for fairness. I mean, because they are very scalable and has been made publicly available, they can be vulnerable to outside attacks or abuse. So what would be Google's policy about such a possibility or risk of abuse?
Yeah, this is really important. So if you look at the Google AI principles that we outlined, I spent a little bit time on, for the 7 things AI should do or be. Number 7 actually outlines that we think that the technologies that we develop should be made available for use by others, by third parties, by external organizations and people for uses that, are in accordance with the principles that we laid out. Now that's very difficult to completely control, right? One thing that was important for us at Google, and I think openness has always been a very key principle of Google. We don't want to just develop all the technology and use it on our own and kind of hoard it so that we're the only ones benefiting. We see actually enormous potential that can be unlocked. So we want to share it with others, right? We publish hundreds of research papers a year. We have hundreds of open source models and data sets because we want people to be able to use them. That being said, that really does, as the person who asked the question, open up the potential for abuse. So there's a couple of things that we've been trying to do to address this. First is we've been quite careful in thinking about what we actually completely open source or publish versus what we do not. So to go back to that lip reading case, what we ended up doing in that situation, we actually open sourced and published a lot of our research, but we ended up publishing a paper, but we did not open source that model because we thought there would actually be, a very high potential chance for abuse there. So these are things that we take very seriously, and every single thing that we publish, we consider quite carefully before it goes public. Secondly, we also wanted to kind of identify kind of guidelines and advice and guidance for people to avoid unintentional misuse, right? So some of the things I talked about, data cards, model cards, we even have a lot of recommended practices and guidance on our website. The idea there was to help steer the community so that as people are using these tools, it's not just a free-for-all, like we didn't just provide a model and go ahead and use it. We actually have some guidance there in terms of how it can perform, how well it can do, and how it might be used. So that's something that we continue to do to try to make that guidance available. And then finally, an idea of, how much can we control? We hope that by promoting the use of AI for good and by having many of these discussions out in the open, by publishing papers and reports and progress, and by seeing many others do the same, there can be a large community, kind of a strong nucleation of people who are developing AI and using it for good purposes with responsible practices and implementation in mind, and that can actually drive an overall good uses for the field and for the world at large.
Thank you. Charina, well, thank you again for joining us today and just sharing the profound insights that you and Google have picked up over a number of years. And ladies and gentlemen, thank you out there as well for joining us for this webinar, and please tune in for the next ones that will be coming up. The next Tuesday session will be a keynote speech by Professor Cynthia Dork about differential privacy. You should never miss it. Thank you. Bye-bye. 감사합니다.
Thanks, everyone.
Thank you.